Hey guys, so this is video 3, chapter 1, section 3. It's called Properties of Numbers, and you can see in parentheses I put real numbers in there. What do I mean by that? Well, actually, what we're working with, and you guys may run into this more when you get into some higher level math, is that there are different types of number systems. And the real numbers, or everything that basically that you've experienced has been a few types of number systems. And I just really quickly want to talk about a little about that because your book, there's truths involving these numbers, right? And the book lays this out in nice little charts. Starting on page, I'm just going to put this page 16, right? And just please refer to that and check that out, because all this vocabulary and these exact these properties are laid out. But I want to quickly mention to you guys these number systems, what they are. All right, so the kind of a few of them. I just want a couple examples. So, for instance, there's something called the natural numbers, and it's like an n. And the natural numbers are a very basic number system where I won't do the formal, writing notation and stuff, but these are all numbers like 0, 1, 2, 3, ... So we don't have any negative numbers, we don't have any fractions or decimals. Okay, so that's like one of the most basic number systems, and that's called the natural numbers. So let's put this here, natural numbers. Okay, the next thing, maybe one step further, would be the integers, and that's it's like this, like a squiggly eye, like that. Integers. No, I'm sorry, I just forgot for a second, but it's a Z. It's a cool looking Z. That's right. It's a cool looking Z. Integers. And those are negative numbers. So this is 0, and then we have 1, 2, ... and then we have -1, and we have -2, ... in the other direction. So we have up to infinity, but again, no fractions, no decimals. Then we jump up to one more complex system, and that's called the rationals. Rational numbers, or I'll say rational. Yeah, rationals is fine. And this is a cool one. It's like a Q, like this. And you could do a double line Q like that, rationals, or a squiggly. I do a squiggle usually. All right, rationals, and what that is, what's rational mean? Or ratio, you guys know ratio, right? And that's including all fractions. So what that is any number from the integers, positive or negative number, over some other positive or negative number. So it's 0 and 1/2 and ... right? But you can have any portion between here, 0 and 1/2. So we could have an infinite number of numbers between 0 and 1, right? Or 0 and anything. We could make a smaller number in any case. We just make the denominator bigger, right? So all numbers and fractions are the rationals. Okay, and then we have one more, and that's called the reals. And that's the number system that we work with pretty much almost exclusively in Algebra 1. We're pretty much only working with real numbers, and that's a cool looking R, like so. And real numbers not only include fractions, not only include all negative and positive numbers, but also include numbers that are like non-repeating decimals. So like things like pi, right? Pi is 3.14 blah, 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 and it goes on forever. There's no ending, so it's not a rational. We call it an irrational number. It's not rational, right? It's a real number, but it's not rational, because there's no way to make it into a fraction of integer over another integer. Okay, and so the real system has numbers like pi. Another one would be like square root of 2, right? That's just a decimal that's just going to keep going. We can keep calculating and never get a nice even integer number over another integer, right? Or we can never get a nice even fraction. All right, so that's just a little bit about different number systems. So our properties, I just want to mention that because you know, the book kind of doesn't really talk much about this, and it's actually really important to and kind of cool to see that there are all these different types of number systems. You know, moving on from the reals, we get the complex numbers. I won't go through this. We get the complex numbers. Then we also have another set number system might be modular number system, integers, mod. Some numbers, and that's another type of number system. Another one is matrices, a matrix of n by n, m matrices, or I by j matrices. So the different number systems, and these number systems aren't necessarily going to have all these properties. That's why I want to go over this, because there's different number systems that don't have all of the same type of properties. The number system we are working in, the real numbers, have all of these properties. Actually, the rationals also have these properties. The integers don't have all of them. They have most of them, but the rationals and reals do. And naturals also don't have all of them. They have some of them. And you know, actually, it's called these two systems are called you know, the real numbers and rationals are fields. And they're different. You know, this is all the way up to like abstract algebra. You'll get this in college and stuff. But just something to be aware of, that there's different types of number systems, that these properties apply to the ones that we're really familiar with, but don't apply to all number systems. That's why I kind of put in here properties of real numbers, because that's really what we're working with. Okay, let's put some examples on the next page. Oh, hey guys, here's a small little quick correction. I just put those backwards. You know, the ABCs. So LMN, so M by N. Just a quick little correction for you. Okay, thanks.